Hello class, in this video lecture we are going to learn about the filters. Before filter, let me remind you, we are seeing the power supply. The first section of a power supply is a rectifier. Rectifiers are the electronic circuits which converts AC into DC. But the output of rectifiers, it may half wave rectifier or full wave rectifier. In full wave rectifier, we have seen the center tap full wave rectifier and bridge full wave rectifier. The output of all these are not pure DC. We call their output as pulsating DC. Pulsating, it means the output is not a pure DC. Pure DC as we want actually like an DC waveform. Instead of that, it contains some unwanted AC ripple. That's why graphically when we plot the graph between the x and y axis, we make a unidirectional AC. Okay, that unwanted factor, that unwanted component is called ripples or fluctuations, which are unwanted, undesired. To minimize these unwanted content in the output of rectifier, we use filters. Filters, this circuit are connected in between rectifier and regulator. Ideally, the output of the filter should be pure DC, but practically it is not pure DC, but it is unregulated DC. The filter circuit we use for the purpose to minimize the unwanted AC component, we called it as ripple at the output stage. As possible as we can achieve this task by using the electronic component, electronic circuitry called filters. Filters, roughly idea, which filtered out the unwanted. Basically, ripples is AC, that is varying with time, while DC is constant with respect to time. Hence, in order to separate out the unwanted AC ripple from wanted pure DC, the filter circuit should be introduced in between the rectifier, as we use the output of rectifier, which we called the pulsating DC, as an input for the filter circuit, and the output of filter, which is unregulated DC, again feeded, again given to regulator circuit. Okay. There are two main components which does the task of filtration, that is removing, minimizing unwanted AC ripples present at the output stage of DC. The concept of filter where it is applied in between rectifier and rectifier and regulator. The two components which does the task are one inductance and second is capacitance. Actually or ideally, the inductance act as a short circuit for DC, but it has large impedance. Impedance here, the similar word for the resistance or opposition for the AC. On the same way, capacitor act as an open circuit for the DC if the value of the capacitance is sufficiently large enough. Hence, in filter circuit, the inductance is always connected in series and capacitors is connected in parallel with respect to load. I repeat, while we think about the inductor are connected in series with respect to load as it blocks and passes, and the capacitor is always connected in parallel with load. The technical definition for filter circuit is as given here. Filter is an electronic circuit component of capacitor or inductor or the combination of both these two connected between rectifier and the load or regulator so as to convert the pulsating DC output of rectifier to desired pure DC. There are types of the filter. Number 1, inductor filter. 2, capacitor filter. 3, inductor capacitor or L section filter. 4th, CLC means capacitor inductor capacitor filter, or simply pi section filter or pi filter. We will see one by one. First is inductor filter. Here the circuit diagram shown the half wave rectifier with series inductor filter. As we talked 1 minute before, inductor is always connected in series with respect to load. Here shown the same. We know the transformer, the step down transformer along with a rectifier diode compose a rectifier circuit. Here only single diode is used, so we called it as an half wave rectifier. Along with half wave rectifier, there is a newly introduced component called inductor. And the assembly of these two is referred as inductor filter or half wave rectifier inductor filter. We know what does the rectifier does. Rectifier converts this AC input into pulsating DC output. As the output stage, it means more clearly when the positive half cycle of input AC is fed to a rectifier diode, then diode become forward bias. At that time, the input is carried out toward the output. Here at the output terminal, it is connected, output lead is connected to an inductor. Here the inductor gives the role that it offers high resistance to the AC component and low resistance to the DC component. That's why AC get blocked and DC is passes towards load resistor. This circuit is also called, or the inductor filter also called, choke filter. It consists of inductor which is suitably introduced in between load resistor and rectifier diode. As shown in the figure, the rectifier output contains AC unwanted ripples. We called it as a ripple factor or components. When the output passes through an inductor, it offers high resistance to the AC component and no resistance to the DC component. Therefore, AC component of a rectifier output is being blocked and only DC component is passes towards load resistors. Theoretically, the output of inductor filter should consist only DC voltage, but practically or in actual practice, it contains a small or a very small amount of AC component. That's why the output of rectifier is called unregulated voltage or unregulated output. The ripple factor for inductor filter for 50 Hz standard frequency is gamma is equal to RL by 1330 times of L. So one should keep, if you want a lower amount where the load increases, it will decreases the amount of ripples. Next filter or second category of a filter is capacitor filter. Here the circuit shown over here, again we use a half wave rectifier and single capacitor is connected in a parallel with respect to load RL. in parallel with the capacitor C, and we know the transformer and this diode, it compose a half wave rectifier circuit. So the filter uses single capacitor connected in parallel with a load in order to minimize the ripple in the output. The capacitor C here used is quite large, of order of tens of microfarad. High value capacitor is used here. The operation of this capacitor filter is depend upon the fact that capacitor stores the energy during conduction period and delivers this energy to the load during non-conducting period. Previously we talked about it that capacitor have a tendency or a property that it can store a charge within it and it release its charge when it is not connected with some DC source. Okay, means whenever a capacitor body is subjected towards some source, some input source, that time it stores the energy, and when we remove that source, the capacitor emits or it delivers, it given to some another this kind of energy. Here in this case capacitor is connected with load, so during its non-conducting or discharging state the charges is passes towards the load resistance. In detail operation should be as like this one. During the positive quarter cycle of an AC input signal, the diode becomes forward biased and hence it conducts. This quickly charges the capacitor to its peak. Peak means maximum value of input voltage, that is V suffix m. Vm sin omega t, that's the actual function of a AC input signal. Practically the capacitor charges Vm minus V omega, or it charges up to its larger magnitude due to the diode forward voltage drop. When the input start decreasing below its peak or maximum or amplitude of the input signal, the capacitor remains charged up to its maximum value called Vm. We are talking about the voltage cycle, so we take it as Vm, V suffix m. It is an amplitude of the AC signal, and the ideal diode get reverse bias. This is because the capacitor voltage, which is cathode voltage of a diode, become more positive than the anode. It become reverse bias, and in a reverse bias condition the capacitor discharges itself through load RL. Therefore during the entire negative cycle and some part of the next positive half cycle, capacitor discharges through, there is only one path for the capacitor being discharged or given our thorough charge to the hand over our charge to the next party, that is RL over here. The discharge of capacitor is decided by the magnitude of load resistance and capacitance value. Time constant, which is very large, and hence the capacitor discharge very little form of Vm. Here shown the charging and discharging of a capacitor. How the capacitor charges, what are their maximum values. When the input start decreasing below its peak value, means peak value here A and C are both the peak values of AC input cycle or V out voltage of a capacitor filter. Here this theory states as similar to the diagrammatical vision. Up to the maximum value, when the input cycle reaches up to the maximum, from where it is start to achieve the maximum value, that is point B over here and point this one unnamed, this rising point or rising end, is actually treated as charging of a capacitor. After when this charging end or charging starts up to the maximum value, that is Vm, and when it is fall down, then the capacitor discharges. It means the path of discharging is from point A to point B. Point B is another point where it starts charging up to its maximum value, that is C. Okay. The capacitor voltage, which is the voltage of a cathode voltage of diode, become more positive than anode. It directly means when it is become forward bias. Whenever there is a positive peak attained or a starting of a positive peak attention, it called forward bias. And after the maximum voltage it gains, it start decreasing, that is during the negative. Therefore, during the entire negative cycle and some part of the next positive cycle, the capacitor discharges through load resistance. Okay. In next positive half cycle, when the input signal become more than the capacitor voltage, the diode become forward bias. Again the capacitor start charging up to its maximum value, that is Vm. The output waveform is again repeated as shown in the figure. The discharging, if the capacitor is from A to B, the diode remain non-conducting. It is off. It is called discharging of a capacitor. The diode conducts only from B to C, rising ends of the input cycle. Okay. Now third one is L section filter or LC filter. The series inductor filter and shunt capacitor. Series inductor, because inductors, as we know, the inductor is always connected in series with respect to load resistance, and at the same time capacitor is always connected in parallel with load resistance. So here stated as shunt means parallel capacitor, and series inductor filter are not much efficient, because why? Only a single stage, only one stage of filtration is happen when we use a single capacitor or single inductor. To get much efficient output or to provide a low ripple at all the load, the capacitor filter has load ripple at heavy loads, while the inductor filter at small loads. If we use the combination of these two filters, it may be performed well than a single use, or we can achieve the double filtration by using both these two components, or we can make a combination of these two to get efficient or more ripple free output at the load resistance. So the resulting filter, when we connect all these two, that is in series inductor and a capacitor with respect to load, then it is called inductor capacitor filter or L section filter or LC filter or choke input filter. There are so many of names over here as per the construction, as per the operation. The name is due to fact that the inductor and capacitor are connected as an inverted to the load. A full wave rectifier which is with a choke input filter is as shown here. As there are two, here is a center tap full wave rectifier is being connected with load and capacitor circuitry. The action of choke input filter is like a low pass filter. Low pass filter, again, no matter if this is new term, we know the capacitor shunting means in parallel to the load. What happens when the AC positive cycle is applied, then diode, the uppermost diode, or whose anode is become more positive with respect to next one, or those get the positive polarity, they become forward bias, and it conducts the output of that conduction is pulsating DC. This output is being passed through the load through the inductor. What happened over here? Inductor opposes the AC component by offering high resistance, and it passes DC component by offering low resistance. Due to this, only DC component is passed towards the output, that is, the output is connected with a capacitor. Again, the DC component which we got by a filtration of inductor is again fed, it is again given to the capacitor filter. So whatever the less quantity of AC ripples is present at the output of inductor filter is being removed by the capacitor filter, and that double filtered output is across the load resistance. So it is a double filtration. We get the more efficient output, less quantity of unregulation, less quantity of AC component. What quantity of a AC component present over here? It is given by the gamma factor, that is 1.195 divided by LC. L means inductor, the value of inductor, and the value of capacitor. The product of these two, lesser the quantity, larger will be a ripple factor. So we choose a large magnitude of capacitor and inductor, so we get a ripple free or more pure DC at the output. And the last one is pi filter or CLC, that is capacitor inductor filter. It is also called capacitor input filter or CLC filter. The pi filter is used whenever a low output current and high DC output voltage is required. It consists of TW, two capacitor as shown over here, C1 and C2, and one inductor which is connected in the form of Greek letter pi. It becomes pi. Hey, this C1 is one arm, C2 is another arm, and the upper overheaded line. So it looks like a letter pi. Mathematical symbolic representation. The pulsating output of rectifier is applied at the input terminal of pi filter. Here is a center tap full wave rectifier whose output is being connected with a pi filter. The filtering action of each component, means C1, C2 and inductance, is as like. If you think about the capacitor C1, then capacitor C1 offers low reactance or resistance to the AC component of rectifier output, but it offers infinite or very large magnitude resistance to the DC component. Therefore, it offers low resistance to the DC component and high resistance to the AC component. That's why the capacitor C1 bypasses appreciable amount of AC component to the ground, while DC component moves towards the inductor. It offers high resistance to the AC component of a rectifier output but zero resistance to the DC component. Therefore, it allows DC component to pass through it and blocks AC component, which could not be bypassed by capacitor C1. Capacitor C2 behaves similar to the capacitor C1. It means it offers low resistance to the AC component of rectifier, but it offers infinite resistance to the DC component. Therefore, the capacitor bypasses appreciable amount of AC component toward the ground and DC component moves towards the load resistor RL. It has been found that the ripple factor in pi filter is depend only on the product of capacitance value, that is C1 and C2. But the DC output voltage will be high only if the value of capacitor C1 is large enough. Hence, for given ripple factor, the filter is designed with large value of capacitor C1. The ripple factor for pi filter at 50 Hz frequency is given by the relation in between 5700 divided by C1 into C2 into L into RL, which is equals to ripple factor.